Welcome to the explainer. So picture this. A pipe bursts in the middle of the night, or, a heavy storm rolls through, and suddenly, bam, your living room is literally an indoor pool. It's a high-stakes, ticking clock reality. Watching water fill your home, yeah, it's terrifying. It's pretty much the ultimate property nightmare. But here's the thing. Saving a flooded building isn't just about showing up with a mop and a couple of buckets. Today we're exploring the absolutely fascinating, highly structured science used to pull a property back from the brink of total destruction.
Let me ask you something. How quickly do you think hidden moisture can spark a full-blown mold infestation after a flood? Well, the answer might actually shock you. In variable climates, like what you see in Ohio, the humidity left behind from water damage can create massive mold growth in as little as 24 to 48 hours. Yeah, no way, right? But it's true. Every single minute absolutely counts. This isn't just a physical mess. It is literally a biological clock ticking down right inside your walls.
Okay, let's dive right into this. We've got a quick roadmap to take the stress out of understanding property disasters. We're hitting the anatomy of a local threat, then the contamination categories, the three-step restoration process, the science of drying, and finally, recovery and code compliance. So, starting with the anatomy of a local threat, basically the perfect storm of vulnerabilities in places like Wyoming, Ohio. We're grounding this explainer in that specific community because it's a perfect microcosm for why older properties face year-round threats. We are actually looking at two completely different enemies here. On one hand, you've got surface water flooding. Think of places near waterways like Mill Creek, where heavy spring rains cause the water to just overflow its banks, directly threatening those lower-lying homes. But then, on the other hand, you have groundwater seepage. In hillside neighborhoods, the surface drainage might actually be way better, but that heavy clay soil shifts and settles. It creates a completely different kind of insidious, hidden threat right under the foundation. Now, to really wrap our heads around that groundwater threat, we've got to talk about hydrostatic pressure. Think of the clay soil around a home's foundation like a giant, dense sponge. When those heavy spring rains saturate that soil, it expands. And this creates a constant, massive physical force, that's the hydrostatic pressure, pushing directly against the basement walls. It actively forces groundwater right through tiny hairline cracks and foundation seams. I mean, it literally turns beautiful finished basements into wading pools. To put that environmental pressure into perspective, just consider the number 42. That's how many inches of annual precipitation this specific area gets, which, hey, is great for your garden. But it's a massive volume of water constantly testing a home's defenses. When those spring downpours hit, that 42 inches easily overwhelms undersized or aging sump pumps, especially in older properties. The exact second that pump fails, hydrostatic pressure wins and the basement floods. But, the threat isn't just the rain. Winter brings its own localized monster, the freeze-thaw cycle. The weather around there is notorious for dropping way below freezing and then suddenly spiking back up. And this pattern, it is brutal on older homes. Properties built between 1950 and 1980, which are everywhere in these established neighborhoods, they often have original cast iron or PVC plumbing running right through exterior walls or unheated crawl spaces. The water inside freezes, expands, and totally cracks those pipes. Then, when the weather thaws, those cracked pipes just burst. Actually, scratch that. They're essentially ticking time bombs hidden right behind your drywall. Moving on to the contamination categories, because not all water is equal. What's absolutely fascinating here is how the exact source of the water completely dictates the scientific response. Because it's not just about how much water is in your living room, it's about what's hiding inside that water. Category 1 is clean water, like a burst supply line. The action required is pretty straightforward. Extract the water, dry the area. Category 2 is gray water. Think of a washing machine overflowing. That contains chemical contaminants, so it requires strict desanitization. But Category 3? Man, that's black water. Sewage backups or river flooding. It is highly toxic, and the protocol completely shifts to aggressive antimicrobial treatment and the total removal of porous materials like carpets and drywall. You obviously treat a clean pipe burst vastly differently than a sewer backup. Just look at the life cycle of one of these disasters and how incredibly fast it escalates. Minute 1. The pipe bursts. Within 60 minutes, you need an emergency response because water is actively spreading through your flooring and walls. By 24 hours, like we talked about earlier, the mold risk officially begins. And if it's handled by professionals, by 7 days, the structural drying completes. So the absolute crucial point here is that every single minute counts. Waiting around to address water damage exponentially increases both the physical destruction and the overall cost to fix the whole shebang. Okay, Next up, the 3-step restoration process, pulling order from chaos. So how exactly do professionals regain control of a situation like this? Well, they use a highly structured 3-step blueprint that takes a property from a panicked, flooded disaster straight back to its pre-damage condition. Step 1 is the emergency damage assessment. That means stopping the act of flooding, classifying the water category, and locating all that hidden moisture. Step 2 is water extraction structural drying, literally pulling the moisture out of the building's very skeleton. And Step 3 is reconstruction and final restoration, putting all the structural pieces and aesthetic finishes back together. Stepping back to that emergency response for just a second, I want you to consider this absolutely crucial number, 60. 60 minutes. That is the critical window. Professional crews aim to reach a property within 1 hour of the emergency call, 24/7. Why? Because stopping active flooding and extracting standing water immediately is the single biggest factor in reducing the total severity of the damage. You gotta stop the bleeding before you can heal the patient, right? All right, let's get into the science of drying, going way beyond the surface. Once the standing water is gone, the real challenge actually begins. Professional crews don't just toss a few floor fans into a room and hope for the best. No way. They deploy an industrial arsenal. We're talking truck-mounted extraction units that can pump out thousands of gallons an hour. Commercial dehumidifiers and industrial air movers are strategically placed all over the room. And, crucially, thermal imaging cameras and calibrated moisture meters are brought in. That thermal imaging is required because, as we know, water hides. It gets trapped behind painted drywall and underneath hardwood floors, where our naked eyes simply can't spot it. The big takeaway here is that restoration experts do not guess. They rely heavily on psychrometric calculations. This basically means using precise temperature and relative humidity data to perfectly optimize the drying conditions for vastly different building materials. For instance, drywall absorbs water very differently than carpet padding does. And hardwood floors, they require incredibly slow, highly controlled drying to prevent the wood from cupping or warping permanently. It's a calculated, scientific process tailored to the exact environment of that specific flooded room. Finally, we hit recovery and code compliance, rebuilding it right. So, once the property is perfectly dry, we reach the final phase. And before a single wall is closed back up, strict standards absolutely must be met. The IICRC S500 standards dictate precise moisture detection and drying protocols. This is basically the gold standard of the industry. Following these certified guidelines guarantees the property is fully dry, which, you guessed it, prevents future mold. Plus, from a practical standpoint, documented adherence to these exact standards is exactly what insurance adjusters need to see to approve claims quickly, fairly, and without those frustrating delays. Let's look at the actual reconstruction process for a sec. Even if a home was built back in the 1960s, the reconstruction phase must adhere to current modernized building codes. This means installing GFCI electrical protection in basements where water was present, ensuring proper exterior wall insulation is packed in there, verifying structural load repairs if wooden framing was compromised, and, of course, securing all mandated permits and local inspections. You aren't just fixing the immediate damage, you are legally required to bring the home up to modern standards. It's all about protecting its long-term value and safety. Which brings us to a critical final thought for you to chew on. What hidden vulnerabilities, from aging sump pumps to stressed pipes, are ticking in your home right now? We've seen how insanely fast water can tear a property apart, and the immense science and precision required to put it back together. Check your defenses. Make sure you're proactively prepared before the next severe weather cycle hits. Thanks for hanging out with me on this explainer, and I'll catch you on the next one.